Welcome and study with Tanzania Institute of Education.
What exactly are these polygons? A polygon is any two-dimensional figure with straight sides. These are all polygons, as are these. Here are some words that you will need to know when working with polygons. The vertex is a corner of the polygon, a point where two or more straight lines meet. A diagonal is a straight line that usually runs from one vertex to another vertex. Adjacent sides are two sides that are right next to each other. In this figure, sides AB and BD are adjacent sides. BD and DC are also adjacent sides, as are DC, CA, and CAAB. Opposite sides are directly opposite each other. Here, AB and CD are opposite sides. AC and BD are also opposite sides. We can also talk about opposite angles. In this image, angles W and Z are opposite each other, and so are angles X and Y. Polygons can also be referred to as being a convex or a concave polygon. All the internal angles of a convex polygon are each less than 180 degrees, because all their vertices point outwards. In a concave polygon, not all of the interior angles are less than 180 degrees. As you can see here, this would be because not all of its vertices are pointing outwards. You can remember this by looking at the word concave. All concave polygons have at least one little indented area in them, like a cave in a rock. If you were to draw in all the diagonals of a convex polygon, like this, you would find that they all lie within the polygon. In a concave polygon, however, not all the diagonals lie within the polygon. One or more of them would lie outside the polygon. Drawing diagonals is one of the ways in which we can quickly test whether a polygon is either convex or concave. A polygon with four sides is called a quadrilateral. Here are some of the quadrilaterals you may already be familiar with. A square is a quadrilateral with four equal sides and four interior angles that are equal to 90 degrees. A rectangle is like a square that has been stretched out. It has two pairs of equal opposite sides, and all four of its interior angles are equal to 90 degrees. A rhombus is like a square that has been pushed over from one side. All of its sides are equal, but its interior angles are not equal to 90 degrees. A kite is a quadrilateral you will have seen in real life. It has two pairs of adjacent sides that are equal and diagonals that intersect at 90 degrees. A trapezium is a quadrilateral that has only one pair of opposite sides which are parallel. If the other pair of non-parallel opposite sides is equal, then we call it an isosceles trapezium. In this trapezium, we have one pair of opposite sides equal, and the angles opposite these equal sides are also equal to each other. Think back to what an isosceles triangle is, and see if you can find the similarities between the shapes. Our last quadrilateral is the parallelogram. This is any quadrilateral that has two pairs of opposite sides parallel. The opposite sides of a parallelogram will also be equal in length. Let's take a closer look at some of the other properties of a parallelogram. The following properties are true for any parallelogram. So if someone tells you that a shape is a parallelogram, you'll immediately know that all these properties are true for that shape. The first property is the one I just mentioned. Opposite sides of a parallelogram are always equal and parallel. Another is, opposite angles of a parallelogram are always equal. And finally, if we draw in the diagonals of a parallelogram, we will find that they bisect. This means that they cross over right in the middle, so that each diagonal is divided into two equal line segments. Let's combine what we know about triangles with what we now know about parallelograms. If a diagonal is drawn into a parallelogram, we see that it divides the quadrilateral into two triangles. Both of these triangles have three corresponding sides that are equal, and their corresponding angles are equal too. What would we call these triangles? We would say that these triangles are congruent. If you're ever given a parallelogram and asked to prove whether it is a rectangle, a rhombus, or a square, how would you do this? If you can prove that the diagonals of a parallelogram have equal lengths, then it has all the properties of a rectangle. If the diagonals of a parallelogram are perpendicular to each other, meaning they cross at 90 degrees, then you can say that the parallelogram is a rhombus. And finally, if you can prove that the diagonals of a parallelogram are perpendicular and they have equal lengths, then you can say that the parallelogram is a square. I know this is a lot of information to take in, but if you know these properties, you can solve any problem that deals with quadrilaterals.